We'll get started with serverless on AWS here, and I'll go over it at a high level. Let me start the presentation here. Okay, serverless on AWS, and we'll go over this at a high level. And what we're going to do today is talk about the serverless model in AWS and the cloud. And then on top of that, at the end, we'll kick off a workshop for AWS Serverless Application Model, which is kind of a open source CLI-based tool that you can use to deploy serverless on AWS, and it helps with that. We will not finish the workshop today. It is a robust workshop. I just want to get you folks kicked off with free AWS accounts that last 48 hours, get you folks the link to the workshop. We can get you started, and you can take that on your own and finish it. You have 2 days. If you don't finish it, please feel free to contact myself or your AWS account team. Where you work, you should have an AWS account team, and we can set up specific workshops for any technology. I will say that I thought I would have 2 screens today, and I don't have my slide notes. So give me a second here as we dive in. So we'll go through an overview of serverless on AWS. We'll talk about some of the patterns and event-driven architectures of using microservices and the new model of developing applications, not just in the cloud, but more in a microservice model. How to leverage serverless to drive business value, and then we'll kick off that workshop. And if you want to dive deeper on serverless beyond what we go in today's presentation, we'll talk a lot about business value and serverless at a high level in AWS. But of course, you can dive very deep. And if you go to this link, serverlessland.com, this is hosted by AWS. It's really a collection of all of our tutorials, workshop, blog posts, free trainings, a lot of content available for AWS serverless and how that works. So 20% of time today for most organizations, only 20% is spent on innovation for the developers. So 80% is spent on operations and maintenance, firefighting, chasing problems on servers, infrastructure issues, chasing down code problems. So in the serverless model, and this is from Deloitte in 2019, what we see, what we want for our customers as they adopt serverless technology in and out of AWS is we would like to shift that paradigm and stop having your engineers, your developers, your IT professionals spend time on what we call AWS undifferentiated heavy lifting, which means you're chasing infrastructure issues. You don't have your infrastructure codified. So when you have an infrastructure issue, you have to dig through logs and find it. You're not being alerted. You don't have robust observability at every layer of the stack. So as we move into the serverless model and modern technologies, we'd like to shift that paradigm and really focus on delivering business logic and business value rather than that undifferentiated infrastructure heavy lifting. So what do we mean? So the main 4 components are agility, performance, cost, and security. When we talk about agility, now if an application is developed to be serverless and cloud first from the start, you've started there now. However, if it's a monolith, you may have to start peeling those layers back to modernize it. But get to market faster and deliver features. Continuous integration and delivery in the serverless model, where you would have a pipeline delivering features constantly instead of doing a major release of software. So you're going to test those features, and you're going to have automated tools, taking advantage of workflow tools as well as some machine learning tools to automate some of that code review and testing. Performance, high performance and scalability. When we look at the traditional model and you're building an application and working with the IT team, how do you test how much infrastructure, how much compute and performance does that need? If you're dealing with a data center, how long does it take to procure that hardware, rack that server? That stretches project timelines, sometimes 6 months to a year. And in the model we're in today, we know that procurement is a problem with everything. So getting servers, we hear from a lot of our customers, is taking 6 months to a year. The project can completely change by that time. So we're talking about being able to deploy quickly on globally scalable infrastructure, managed or unmanaged. AWS has a robust catalog of services that allow you to turn all the knobs you want. If you want to control that infrastructure, or if you want to use a managed service, you can deploy your application to one of those and it will scale the performance for you behind the scenes, taking that control plane out of your purview and some of that lifting put on the cloud. Cost, you're going to pay for what you use. This is the big paradigm shift from traditional IT. So you're paying for the value At the end of the day, it should be a lower total cost of ownership, as you have to take into account what are you paying after your full migration. Say your business is modernized. You're not necessarily paying for that power and cooling and data center operations. Maybe never going to get rid of a data center, but taking those large compute applications and shifting that compute to a utility model where you only pay for what you use and design that application to scale with the usage. So when you have a high load, that application should scale to the load and meet the requirement. And then when that load decreases, your compute should decrease to have that baseline. Look at something like Amazon Prime Day. Amazon is certainly not building infrastructure to always meet the Prime Day requirements. It is scaled. Amazon.com being the biggest customer of AWS. People don't realize that it's two separate wings of the company, and they're actually a customer of AWS. And then cost, that's what we were getting into that. And then security is job zero at AWS. So we'll get into a little bit today how deep that goes, but the zero trust model in the AWS cloud is something that is built foundationally. And we have what's called provable security based on machine learning algorithms and provable models. So for example, me as a solutions architect or any of our technical people have no access to your AWS accounts. This is what we call the shared responsibility model. AWS is responsible for the security of the cloud, core networking, core infrastructure, making sure that stuff is secure at our data centers. And the customer, once you get your AWS account, you are responsible for security in the cloud, setting up your own security rules, your own security groups, and controlling that data flow. However, we have partners and myself and account teams that are here to help you with that. What are customers building with serverless? Well, the first thing, and I hinted on this, is IT automation, infrastructure as code. Deploying traditional web server models, for example, that might run on Java or .NET or another framework. Deploying that maybe in a hosted web environment, like we have something called Elastic Beanstalk, that's a serverless managed service, or building it on containers or even servers, but codifying that infrastructure where you can deploy it with a couple clicks. And if there's a problem, kind of treating that infrastructure as disposable and not chasing the issues, but logging and doing a post-incident analysis on the logs instead of the hardware itself. So when there's a problem, destroy the infrastructure and let new infrastructure be created. Data processing, building infrastructure, and this is my background. I have about 17 years in IT, and the last 7 years was spent building enterprise global data pipelines and migrating data tools to the cloud at a sneaker manufacturer that is local to Oregon. So I spent 7 years there, and I came to AWS about 2 years ago. But the level of large data processing and being able to build that on an on-premise environment has outpaced most institutions. So when we look at data processing and storing large amounts of data in something like Amazon's simple storage service, it's global scale and availability, far more than most organizations can build. And then the data processing on top of that, whether you're using big data processing like Apache Spark through, we call it EMR, Elastic MapReduce, or AWS Glue is another processor we can use, but large compute available on demand. Web applications, one of the simplest uses of microservice and serverless, deploying web applications serverless. So you don't have that infrastructure to manage. You're only managing the pieces you need to for your application. And as we see our customers mature, machine learning and heavy machine learning processing algorithms take heavy compute, whether they use our machine learning services or build models themselves, a common use of especially EKS and Kubernetes. So serverless, what we talk about in AWS here is these small pieces loosely coupled. So traditionally you would have a client server system where you would deploy your application. And I'm going to apologize for all of the AWS icons here without explanation. I'll go into some of that here in a second. But it's just showing you that all of these services can essentially be used as building blocks in AWS to piece your application together for what you're trying to do, rather than deploying servers and then building this full stack on top of a server to host your web server. In a really legacy model, you may have your database on the same server as your web server. And then how does that front end connect back to the web? So when we use our loosely coupled model, you would have your front end app and your application consumers coming in and you'll see these API endpoints here. So using services like we have, like API Gateway, you can then direct that traffic to serverless things like these little alpha looking icons, or what we call AWS Lambda, and we will go into that today. And that is just a serverless code execution service that kind of would make calls based on events to trigger the next part of that workflow, for example. So more than compute, I'm talking about compute here, but kind of breaking down the layers of what we mean by serverless. And it's pretty much anything that we're hosting that's not that you're not hosting on a server. We all know behind the scenes in the large AWS infrastructure, this is being hosted on servers somewhere, but your consumption point is going to be a serverless model. So AWS Lambda being the foundational compute, I like to call it the stitch that ties the things together. AWS Fargate is a traditional server scaling. If you look at EC2, which is our virtual servers, Fargate does some of the scaling for you. So if you deploy something, it might scale that instance for you. And I talked about data. So data stores, S3 being the largest and most resilient object store available in the cloud. Aurora Serverless is a global RDS Postgres database that's available without you managing any infrastructure, and DynamoDB being that NoSQL database. So if you have unstructured data you need to store, key value store, it can work as it's a great key value store, things like that. And then finally, the integration pieces to tie all this together. API Gateway being that gateway to take connections in to whatever APIs you're connecting to. I won't go into all these. Event Bridge is our event engine. It used to be called CloudWatch Events, but now we call it Event Bridge. This is event-driven architecture. So say somebody drops a file in S3, you could have an event bridge event to trigger something. Say you have a auto-scaling event or a compute event where something has gone past a threshold, that could be an event to trigger something. So any event that happens could be a trigger to trigger the next thing, whether that's an auto-scaling event or some type of application component event. And then SQS is a queuing service. So you want to decouple your architectures. So if you don't have a queue set up and you reach a threshold, you're going to drop requests, you're going to lose them. So putting them in a queue, whether that is a first in, first out queue, or however you want to configure it for your application. Notification service can be used to both notify you through email, through text message, your account team, but also to notify Lambda or another service to do something. And then step functions, kind of look at that as a batch to kind of workflow to tie it all together. So now if you talk about the operational responsibility, there's a lot of layers here. So this is kind of the paradigm shift of traditional IT and then doing serverless and cloud-based applications. So compute, you would traditionally have virtual machines. Now you have this whole spectrum. EC2 would be traditionally what on-premise would be considered a virtual machine. You can deploy a Windows server, Linux server, you manage the infrastructure, you size what the server is in AWS. Elastic Beanstalk is a serverless application management engine where you can just drop your Java.NET application in there and it will manage it for you and serve it up. Fargate auto scaling infrastructure, like I said, and Lambda, I've already talked about the serverless compute. When we talk about databases, traditionally you'd have your SQL Server, MySQL, Oracle, whatever database you may have. We're using just MySQL as an example here. And then if you go across the spectrum, RDS for MySQL, which is relational database service, that is you are managing the database. However, the infrastructure behind the scenes will be managed by AWS. So you still have all the access to your data. You don't have to worry about the patching of the server, things like that. So you're going to host that in RDS, Aurora being that global, and then DynamoDB being that key value store and NoSQL database. If we get to storage, it only has S3 highlighted here. Well, that's going to be your serverless large scale storage, object storage that all of our services tie in with. There's also EBS storage if you need server attached storage or NAS type storage like that. And FSX is something we have that connects to Windows for storage. Messaging, we're talking about SQS, SNS. Kinesis is our streaming data service for any type of real-time streaming data, clickstream data, things like that, that you can bring in and process in real time. And MQ is a managed event engine. So, and then of course, analytics, I could go deep here, but that's not what the session is about today. But these are the services for big data processing and analytics on the cloud. So we'll go into a little bit of Lambda, because if you are building serverless applications in AWS, you are going to use Lambda a lot. So here's a basic, really high level diagram, being Lambda event source, your Lambda function, and then that will call the services. So basically you're going to take an event in, it's going to change the state. I'm just giving you examples of there. It could be a change in data state, request to endpoints, change in resource state. Remember, if I said there's too much compute or too much memory, the resource is at a constraint, it will trigger a Lambda function for you. Here is some of the languages that it supports. .NET is also supported, I want to call out. And then that will trigger another service. So the anatomy of a Lambda function, this is kind of a very basic one here. So this is just going to process your event. So function configuration, you can select your memory and it will allocate CPU and network proportionally. You're basically sizing your Lambda function off of how much memory it needs to run. So you can power tune it to balance cost and speed. Of course, the more compute it uses, it'll cost a little more. But Lambda is not a high cost service. It does run very quickly. It's a simple code execution. And I believe it has a 15-minute timeout, and I'll get to that on the next screen. When we talk about zero trust, you need to set up what we call IAM roles in AWS. It's identity and access management. So you're going to have roles, and setting up that zero trust. Only the role should only be able to access and function what that function needs to kick off that next service and nothing more. So this is where we talk about separation of duties in the serverless model. You don't have a server admin that can log into the server and have access to that full stack. You should have a data person, an application developer, and maybe an AWS admin, but each of them should own that level, and the IAM permissions should be granted accordingly to the functions. 15-minute timeout can be synchronous or asynchronous. And when it talks about network access in AWS, we have security groups that are groups based on both network and identity that control your access to your services. So that's an extra layer. So you're not just blocking IP addresses. It has to match network and identity. So this is an extra layer of zero trust. Hopefully you're going to have a key management service like we have built in, where you rotate the key and it's a unique identity each time that function makes a call to that service, completely logged on the API backend. So you would never have, if a key was compromised, that's simply a temporary key that expires after that one-time use. Built-in monitoring, of course, with all the services. This is a quick example. And you may see something if you go into your CloudWatch events later after you build the workshop. But you're going to get, it's telling you how many times your invocations were, duration, built in. And this also can tie in with your existing SIEM or monitoring software, and you can output this to look at it elsewhere and manage that data. So go build something, of course. Like, it's very easy. I think you'll get an idea today with some CI/CD work if you get that far. And right now we're going to go over just some reference architectures and event-driven architectures before we hand off to that workshop. And I think we have until about 3:30. So hopefully we'll get a good solid hour or so to get the workshop started. And I'll be walking around to help you folks as well and watching the chat. So just some generic patterns that we'll go over at a high level, just to give some more ideas of serverless architecture and the patterns that it involves. Event, it's just something that happens, right? So yeah. So API-driven architectures, API defines the interface. When the API is called, the caller should expect an immediate response, still event-driven because the call is an event. And then the client must implement error handling and retry logic, right? Because how many times does it need to retry if the API doesn't respond? And then event-driven, a pure event-driven architecture, the payload defines the interface. So message received or not. And that's asynchronous processing. It does have higher resiliency because you're not client-based, you're not waiting on client requests, and it's typically driven by a messaging service or enqueued. Built-in retry, so this is where we're going to use like our SQS service to queue the messages. And then if there's a failure, it should be able to retry. So event-driven architectures drive reliability and scalability. So you're abstracting the layers. You're abstracting the client requests, producers, and consumers. You're not having dependencies. If one service goes down, your whole application goes down. So if that was one point of the workflow, anything that has passed that point of the workflow will continue to process. And if you have a proper queue set up, the request will continue to queue while that service is down. Once it's repaired, the entire workflow should start working again. Now, I realize this is all very high level, and in a real world, you might be decoupling applications that are already built. So keeping that in mind, we see a lot of customers, if they need to migrate a workload, for example, they may do what we call a lift and shift and migrate it on that traditional EC2 model. And then once it's there, they can start peeling the layers of the onion, if you will, back and working on re-architecting for the serverless model once it's running in a cloud. So I won't go over every one of these bullet points because I feel like I've touched on a lot of these, but of course your messages, events, choreography with Event Bridge, that's where the events are going to come from, and then you're going to orchestrate with step functions. And you can orchestrate, of course, with your language of choice. AWS integrates with Puppet, Terraform, et cetera. So API-driven use case is also event-driven, but synchronously processed. So RESTful API microservices. API gateway would be the foundation here of essentially intaking those requests into AWS. And then that would pass that on to Lambda and then your other DynamoD key value store, however you want to set that up. And then with enhanced observability, this just shows AWS X-Ray and CloudWatch, some of the observability services built into AWS that would help you monitor the availability and performance of your application. And this is where you could also use a CloudWatch alert could be sent to Event Bridge to trigger an auto scaling event, for example. Event-driven, this is the simplest use case, is processing file uploads. Like if somebody uploads a file to S3, it would trigger a Lambda event to do something to that file, whether that's push it into a data pipeline, whether that is if you're doing an image sharing service and you need to move that file to a specific user's location or put some security around it. This is the simplest event to use as an example. So if a file's dropped, it's going to trigger something. In the inverse, like I already talked about, you could have a performance event that would trigger an auto scaling event or something like that for your containers or your servers. So this is adding more functionality. So we have Amazon recognition. So if you wanted to have the file dropped, it's going to trigger a Lambda to send that to recognition, which is an image recognition services, and scan the image and find out what's on it. This is how, for example, Amazon warehouses work when they scan the packages to automate where they're putting them. It uses Amazon recognition. So here's something I'm very familiar with, is consuming and processing streaming data. So you have the application feeding into Kinesis. So your clickstream data, email clicks, anything that would be real-time data flowing in, traffic events in the public sector, anything that's tied in with that. That's going to trigger Lambda functions, and it will send the raw data to S3, unstructured data, if you have unstructured tools you want to run against that. And then it shows it putting some of the process data into Amazon Redshift, which is our analytics warehouse database for high compute analytics use cases. there any questions before this? I think I'm about to wrap. So just a couple more examples. Are there any questions so far? Mm-hmm. SQS would store the messages. It can be a trigger for a Lambda function. So if you're queuing events there and you want certain events to trigger a Lambda, it's all based on how you set your application up and the way you do your workflow. So what's that? It depends on how you set up your workflow, because SQS is a queuing service. Remember, it's not going to send events. So if you want Lambda to watch SQS and have it trigger based on how many messages are in the queue, that's a common invocation of Lambda, because if you're starting to queue too many messages, then you know you have a bottleneck somewhere. So that would be a trigger. That would be a typical scaling event, for example. Yeah, and then you need to set up your Lambda function to watch, and then you would send that to EventBridge. So, yep. Okay, so the question was, can SQS be used as a trigger for Lambda? And the answer is yes. Typically, you would see that if your messages were queuing too much, and that would be a bottleneck event. So you might trigger a Lambda to auto scale containers or infrastructure, for example.
Third-party VPN or you talk a little bit about that. Is obviously an entry to overall software quality.
Yeah, of course. I'm talking about AWS native functions right now. However, if those marketplace or partner offerings, especially if they have API endpoints that you can work against, of course, it would tie in with API gateway and you could talk to it that way. It depends on the solution. Every marketplace solution won't be completely integrated with every AWS service, and some of them are. So it would depend on the specific marketplace solution and how they've architected it to deploy within AWS. Yeah, so the functionality is almost the same. GovCloud will have a few less features that lags a little bit just because of some of the auditing and the compliance controls that GovCloud has to go through. But the functionality should be the same. What GovCloud has is you're going to get CGIS compliance, you're going to get FedRAMP High compliance, something like, I don't know where everybody works here, like ITAR, International Weapons Trading, like that type of compliance. And otherwise, commercial cloud is FedRAMP moderate compliant, it's HIPAA compliant, it's PCI compliant. I would always direct customers to use commercial cloud as a default, and GovCloud only when their compliance mandates it.
So in which US-based commercial cloud will be maintained by function.
So the staff wouldn't be off store maintaining like the infrastructure, right? Those data centers are all within the United States, and separation of duties. I can't answer your question completely, but I have no access to the data centers, for example. But I can get a GovCloud account for myself because I'm a US citizen. So you do have to be a US citizen to have a GovCloud account and to work on AWS GovCloud, period. Yeah, well, you can define, of course, which region you want to go into, and you can completely control where you want your data to be. If you want it to be just in Oregon, for example, Oregon being one of the states that has that benefit, because we have one of our largest regions here in Oregon, that you could keep everything in US West or US West 2. And GovCloud West is also in Oregon. Yeah. Like I said, I would have to look at the list. There's a few services that aren't available in GovCloud. Most of these should be, but some of the overall, I want to say like management, like a control tower that manages all your accounts, because of the way the API hooks work, sometimes that's not compliant with GovCloud. So it's all public available. I can get that list out as well on what services are and are not available. But like I said, there is a cost difference too. GovCloud does have a slightly higher cost associated with it. So. A fan out. This is fanning out messages through Events Bridge. So this is kind of multiple queues. So Event Bridge is sending your processed, like this is a order management system, for example. So multiple queues for refunds, returns, processed orders, and orders created. So 3 different workflows. Okay, AWS SAM. Now we're going to get into SAM. Serverless Application Model is what it stands for. All SAM is open source, so it's free to use. It's a template specification. Using the CLI and tying in with your tool of choice, your software dev tool, or if you want to use AWS, like in the workshop today, we'll be using Cloud9, which is AWS built-in IDE. And then, yeah, it'll give you single deployment configurations. It extends CloudFormation. You can deploy the CLI locally on your machine and do local debugging and testing before you deploy to the cloud. And then a lot of the built-in best practices. And you can also contribute to this on GitHub. So SAM kind of just helps tie all these components together.